Hello everyone. Today we are going to discuss with respect to the hackathon, will the patient survive or not? For this I have created a folder over here, and the text which was given to all of you is that a hospital has been trying to improve its care conditions by analyzing the historic survival of its patients. They tried looking at their data but could not identify the main factors leading to high survivals. The data set has been divided into two parts. One is the training and the testing. The dataset column information, what does each column describe, have been shared with all of you. Objective: to develop a model that will predict the chances of survival of a patient after 1 year of treatment. What does you require for this particular dataset hackathon? Is that you are required with the Python 3 version, Pandas library, scikit-learn library, Seaborn, Matplot, and NumPy. How the evaluation of the model is being done? It will be done on the basis of recall parameter. The participants who are joining for this session, they can submit the Python file as Jupyter file as well as the text file, sorry, CSV file, the submission file. So you are required to train the model on the training set, and on the testing set, what all you receive the results, you have to share it in the form of a submission file. Once the submission file is being received, your answers are evaluated on the basis of the test cases which we have done at the backend, and the person who will have the highest recall parameter is going to win the hackathon. We are going to create a new file over here. Hackathon solution. So will the patient survive after treatment? The purpose of this solution we are providing over here is that to go with the flow of the ML model. It is for reference purpose. You are requested not to please consider this as the exact solution and the exact approach. With your solution and raise, or not to compare with your solutions, and use for reference only. Okay. First thing that we do is to import the relevant packages. Okay, the relevant packages that we have over here is first of all pandas. So import pandas as pd, import numpy as np. These are the two relevant packages that you require, along with visualization packages. Import Seaborn as SNS. Solution. Now over here you will be given the solution approach or solution for all the models. In detail, flow and concepts are shared in the sessions. How we have come down to this solution, the best solution, we all teach this in the machine learning classes. Over here I am directly using the higher end, which one is giving the best answer. and which one is not giving the best. So we're going to compare all of them. The file which I need is df is equal to pd.read_csv survival, or what is the file name? It's survival.csv, and the head looks like this. What is the size of it? So we have a total of 23,097 rows, 18 columns. After performing a much deeper analysis on that, I understood that what are the columns that I require and which columns I don't require. So I'm going to prepare with respect to that. Looking at the statistical things which we have discussed in the webinar, it will be covered. You can do all those things. So describe, it tells you all the statistical parameters. My question is on the last column, survived 1 year or not. Has the person survived or not? So over here you can see that just look at the minimum maximum, because only two values I have for the survive. So df for survived 1 year dot value counts. Now you can see over here 14,603 records are for the people who have survived, whereas 8,494 people have not survived. We have to make a prediction that any unknown data set is given to us out of the test cases, the person who will be able to survive and which is not able to survive. This is what you have to find out. The next step over here I will be taking forward is to only consider the relevant columns. Only and only relevant columns. So my relevant columns, and there is one more thing over here, which is patient care, diagnose, ID, age, ABCDE, df1 dot columns. Oops, df, sorry. Patient smoker, it comes after patient. Achha, this is a describe, sorry, in head. Patient care, patient smoker is over here. Now there are three categories for the patient smoker. So df dot patient smoker dot unique values. You can see we have three unique values over here. I'm considering only the values which are on either yes or no. For the cannot say, it's on you what you like to do. So it's just a general flow how we can approach the problem. The objective of this particular data set is not to give you the best recall, but how to get the recall. So I'm creating a copy of it is equal to df dot copy. In this copy, we are only and only looking at the data set where my patient smoker is not equal to cannot say. So is equal to df1 df1 dot patient smoker is not equal to cannot say. Spelling should be correct. That's it. So we are only taking the data set where we have yes or no. Run it. Now in df1 you can see we have either yes or no. So we have reduced the size of the data set also. Now we have 23,084 df1 dot shape 23,084. Earlier I was having 23,097. So very few records we have for that. Only 15 records we have for that. So there is no use case of it. We can directly drop it. Even for the test case, if you find something, you can remove that thing. We are not looking forward to work on that. The columns, okay, relevant columns that I have learned after performing EDA is as below. Yours can be different one. You can keep all of them, you keep one of them, it's all your choice. So few of the columns that I require. So df dot columns. I need my treatment with drugs, patient age, body mass index, smoker, rural. So I will first copy all of them. Body mass index, process, rural, and mental condition also I need. So your mental condition and till here. What I have not taken, I have not taken ID. Care situations, this ID is not relevant while going for machine learning. Diagnose condition. So if you're looking for a diagnose condition, df dot diagnose condition and dot hist. This is the histogram of the diagnosed condition. How many times the person is being diagnosed. I'm not taking care of it, as when I cross-checked, it was not giving me much contribute while performing any of the it is not contributing while giving the prediction. So I'm not taking that one. Same for patient ID, I'm not taking care of. Only from treatment with drugs till the last number of previous conditions. This we are looking forward to take care of. Of course, this thing should also be taken, as currently I have not splitted the model. These are the columns I will be taking. So I'm asking my df1 to be equal to df1 wherever you find all these columns. So df1 dot shape, you can see it has been reduced from 18 to 15 columns. Okay, so we have only and only taken the relevant columns. The next thing is to find out if there is any null finding, null values. You can write here df1 dot is na and is sum. You'll find we have a b c d e f z. Now these are all uncertain columns. That is the extra information which the dataset has shared with us, but with no meaning. If there is no meaning for that, I don't know how I will be able to fill it. What you can directly do, if you look at the data set, so my survival.csv, you can see maximum of that a b c d e f z, they are nothing but 0 0 0 0 0 0 0. So even if they are having null values, like say you have having 0 0 0 1 0 0 0, maximum cases you are having 0 only. So I can replace those null values where you are seeing commas here by those 0 itself. It's my understanding, but of course it can be different for yours. Again, I'm saying the purpose of the dataset is to give you an overview how a machine learning is being prepared and how to get the recall parameter, but not the best recall parameter for you guys. For best recall parameter, what I can take while comparing all the models. I'm hard coding it, this thing, so we can write on df1 is equal to df1 dot fill na by 0. You can write here string, sorry, numerical 0. Numerical 0 because df1.info. You can see here A, B, C till Z, they are all floating point numbers. So directly writing the numerical 0 is going to work. If it was a object type, let's say treating with drugs, or it is yeah, only one, or it is your smoker, ruler, or condition. If it is an object type, then I would have taken string of 0. But numerical 0 is more than enough for this one. So filling NA values. So A, B, C, D, E, F, Z. A, B, C, D, E, F, Z. So last one is unnecessary. Same goes for the left side side. A, B, C, D, E, F and Z. It's done. As you can see, the number have been written over here. We look at the above, run this just above once more. You can see everyone is now 23084 non-null. You look at the above, fill NA again. Now everything is 0 except this number of previous condition. So number of previous condition is the only left one. Number of previous conditions, how you can fill it? For that you can take a mean or median. So df1 dot number of previous condition dot mean. The mean is 1.75 and you look forward to the median, that is 2.0, and my unique values, or let's say the histogram which I have for this column, histogram, that is, you can see here it's 1 2, majority of them are 1 or 2, and then we have 3 also, 4 also, and little bit of 5 also. So as you can see on this data set, or let me give you further bifurcation once more, unique. So you can see the values are 1 2 3 4 5 and NA. So it's very clear that filling it with this 1.75 will be wrong. Filling with 1.7 will be wrong, as it is going to add a floating point number. I don't want a floating point number, I wanted some discrete number out there. How I can have a discrete number out here? By simply writing a median value. So I'm going to fill this particular column by a median value. Okay, so this column is equal to this column over here, dot fill NA by median. Done. Now you look at this histogram again. You can see there's a sudden increase in 2. The NA values have been imputed over there. Unique values for all of them. NA value have been removed. Now 2 is the one. So we have removed everything, every NA possible in the dataset by our normal uh, brute force, by replacing A, B, C to 0, and the other with respect to the particular columns. Okay. Okay. Now we are going to set up the classification ML experiment. For this I am using my PyCaret. PyCaret actually compares all the columns. Okay, so from that you can write here from PyCaret dot classification model. Why classification model? As my survival is either 1 or 0. The survived case is either 1 or 0. So I'm using simply classification methods, import star. If the PyCaret is not installed in your system, request you to please install it. It can help you provide the analysis for all the models. Secondly, it is also going to provide you the in-depth chart. So from PyCaret, we are now going to work on the classification ML experiment. We will name it as classification ML setup. From there, we also have a setup parameter where we are going to pass the data. The set of parameters that we have here is that data, target column name. So name you have to pass over here. On this data frame, it will automatically identify what is the target column. You need to have your categorical features also. That is all the names you're looking forward to apply a ML model. And apart from that, you might have. Okay, let's complete it. So data is equal to df1. My target is equal to, so your df1 dot columns. Out of these columns, which is columns you need to have over here for comparing them is till Z. This I have done after performing all the analysis. So I'm deleting the age and body mass index, the numerical columns I'm deleting. And after this page, 1, 2, 3, 4, yeah, the rest is correct. Categorical features is equal to cat calls. If they are correct, so these are all the columns that I have, and if it is correct, so df1. Okay, so I can see parent, and so it identifies the categorical columns. That's why you can see here I have removed my patient age and patient body mass index. It has automatically identified these things as numerical. Rest of them I have to identify the categorical. So I have to just press enter. So following data types have been inferred automatically and it's completed. Now what does it show? It tells you what is the target column from the data set. Target data type, that is the boolean. Either the person has survived, yes or no. Label encoding not required. Original data set has 23,084 rows, 15 columns. Missing values, there is no missing values as we have already filled the missing values. Number of features, that is 3. Categorical features, so numeric features is 3, categorical features are 11. As you can look at the data set again. Okay, df1 dot info. I have patient age, patient body mass index, and your survived 1 year. These 3 features are numerical. Rest of them are categorical. So 3 numerical features, categorical total are 11. Ordinal is a part of your data type. So high cardinality features none, cardinality method none. Transform data set. So it is giving your training set as per the 70%. It is giving us 16,158, and test set is 6926. Shuffle train set true, shuffle train stratified train set false, fold generator. These parameters you can also change over in the function itself. So using the pie-caret setup, I have compared many factors available here, but this thing we have only done after once I have learned the entire dataset flow with respect to only one single model, simplest model. So I'm giving you a pie-caret to compare all of them. So there are many parameters over here. You can understand. Take time. Little bit high level, but this again is for the reference learning purpose. How we compute for all the models in one go. Next thing that we do over here is to compare the model. So it's very inbuilt term, compare for the pie-caret. Compare models like this. It's going to consume some time on the basis of models. So after comparing it for a couple of minutes, it is able to find the best model which is giving the answer. Now you might have tried for all the models in the categorical, KNN, logistic regression, or extra trees classifier, random forest, adder booster, all the categorical type of classification, we are able to receive the answer. And these are time taken in the seconds for all of them. So out of these, comparing all the models, we have found the gradient boosted classifier, giving the best one. Now you can directly also take this classifier and get the best parameter inside it. So model is equal to create model. Over here, please pass on the correct name. It is the name what is written over here, GBC, not the model complete name, but the abbreviation is more than enough. And after changing the parameters in build, it's going to find the best one and give you the answer for all the parameters. After spending a few minutes, we are able to see that the best one, best recall is 0.8799 within the gradient boosting classifier. And what is the mean? What is the accuracy? What is the mean accuracy? What is the mean AUC and mean recall? So after this mean recall, we can see that the very first fold gave you the best one, I think 0.88, and then we have 0.989 also, and then we have 0.89. Yeah. So at fifth fold, we have the best recall, that is 0.89. Now you, while completing the task, might find the best one available. Over here, we are able to see that at 0.89, we are getting the best accuracy, fifth fold. And you can compare for accuracy, AUC, recall, precision, F1, kappa, and MCC also. Okay. So this video is just for learning purpose. You can take it as a reference how a flow is being done and comparing all the models. You have worked a single model, so I'm giving the answer for all the models for you in this particular video. It's a little higher end as we cover with the different models. So I hope you like this video. Please look it for the reference purpose and approach for any problem. And that's it. Thank you and take care, everyone.